Okay, so good afternoon, everyone. My name is James Dennis. I'm a software engineer at ZeroStack. I have been a Python developer for probably about 8 years now, and I'm here to talk about some Python basics, which I think are pretty useful to know when you're operating OpenStack. How many Python, do we have any Python developers here who have done any Python at all? Anyone wants to throw their hands up? 1, 2, okay. All right, good. Okay, so let's go ahead and get started. So obviously there's a lot of stuff you could talk about when you're trying to talk about basics here. So what I've come up with here is some topics I think are most useful. So we'll talk a little bit about Python itself as a language, just briefly, and then move on to the Python logging framework, which is pretty much what every Python application on the planet uses because it's so fully developed. And then threading models, which are used in applications. Primarily, we're going to talk about these because it affects logging, and so you can try and figure out, what's going on when you do that. Those of us who've worked with OpenStack are quite familiar with the Python backtrace, stack trace that appears in the logs. So we're going to go over one of those, and so you can learn how to read it and get some useful information out of it, and also how you can actually add some additional logging yourself to the code. Say you've reproduced the issue in a test environment, and you want to add some additional logging because some of the variables that you need to figure out what's actually going on is not present. Okay, so Python, it's a dynamic interpreted language. There is a bytecode intermediary format, PYC files, which you're probably familiar with, you've seen. But for all intents and purposes, it's an interpreted language. It's object-oriented, so typically applications are written with classes. It doesn't have to be, but any large application, that's how they do it, use inheritance so that you can reuse common code for different types. Exceptions are used for error handling. I'll talk about those. And one of the things that most people who aren't familiar with Python think are a little strange at first is that there's no curly braces, that indentation is used to mark like the control block for like while loops or for loops, stuff like that. So Python's been going through a transition since 2008, which is not quite as bad as Perl 6, I suppose, but it's been going on for a while. And essentially what happened is that there are, Python is known as a language that's fairly easy to read and kind of tries to make sense when it's read. And there was a couple of things in the language which they thought they could improve upon, and one of them being all strings by default in Python 3 are Unicode, and Python 2 there's not. So a few changes like that meant that the language, it was not possible just to take Python 2 code and run it on Python 3. So that meant that people have been slowly porting things towards. And this is something that OpenStack has been working towards. There's a link there that you can go to and you can read about their progress so far. So when you're reading online about Python 2, Python 3, most deployments I would expect, if not all of them, are currently using Python 2. 2.7 is the latest release. They do keep coming out with point releases like less than that, like 2.7, 0.11 for security issues, but the benevolent dictator for life, Guido, who runs Python, he says there is not going to be a Python 2.8. Okay, so moving on. Okay, so how are Python modules, applications actually structured? So they're structured into modules and packages. A module is a single file, .py file, which is a collection of definitions and statements, actually the core logic. And then a package is a collection of modules which are held under a directory. And what you can actually do, you put packages inside of packages, and you can build this hierarchy of functionality. So the example I give in here, which I took out of the Python documentation, is you've got sound.effects.echo. So echo is the .py file, and sound and effects are these directories. So when Python code has an import statement in it, what it has to do is it has to go to the file system and it has to try and find a file, a module that matches that structure that you've given it into the import statement. So the way that it does that is it has certain locations that it's going to look for those directories and those files in, and that's controlled by this sys.path variable, which is built into Python. And so the example of, it's a list. You can actually manipulate it in Python code too if you wanted to add additional directories to be searched for. So the example which I'm giving here is actually what you see on Ubuntu, and specifically the OpenStack packages are in that dist packages, which is like the penultimate entry in the list there. So typically that's where you'll find Nova and Neutron and stuff like that if you're trying to find the source code. Okay, so what does an import statement look like? So I've given two examples here. They do look for the files in the same place. Really what the difference is between these two is how you then access that module in the code itself. So with the first import statement, if you wanted to get to that echo effect class that I put there as an example, you'd actually have to put sound.effects.echo.echo effect. So the second one is sort of a way to import echo directly without having to do all that typing. So this example, we have a class called echo effect, and it's located in that location there. So the import Python, when it saw my import statement, it searched through and it found that location. Okay. So the other place where this is useful to know with OpenStack is that you've probably, when configuring Nova or Neutron, sometimes you have this concept of a driver, and you've gone to some documentation. It tells you put this long string with dots in, and that will make it work, right? So this is actually what's going on under the hood, is that it's turning that into an import statement followed by a class. So this one here, the network API class, which is a driver in Nova, what it does is it goes to that location on disk and it instantiates that API class, and that API class implements certain methods that Nova expects. Okay. So I was saying earlier is Python has an extensive logging module. In fact, it has 3 chapters in the Python documentation, and just shipping with the standard library, which every Python installation have, there are 16 different ways to handle logs that are generated. Right? So I put 3 examples up here. Some of them are derived from the others, so I suppose 16 is a little bit of an exaggeration, but there really are 16 classes. So you can configure everything from just saving a file to a disk to writing your own or having them sent to an HTTP server. By default, OpenStack uses one called the file watch handler, which is one that logs to disk, but is also good for using with log rotation. Okay. All right, so logging levels. So the log levels that OpenStack uses are derived from the Python logging package, apart from the trace one, which they added, which is typically used for tracebacks. So critical is the least verbose. So that's saved for really bad things. I'm not sure I've ever seen OpenStack omit a critical. Typically I see errors and traces. And then debug is the most verbose. So if you really want to get a good idea of what's going on, like what decisions Nova scheduler is making or something like that, then really you want to get that debug level. So one of the powerful things, and also sometimes something that people complain about with Python, about the complexity of logging module, is the fact that loggers themselves actually exist in a hierarchy, much like packages. And what this allows you to do is actually to configure different log levels for different parts of the hierarchy. So for instance, this hierarchy here, which I presented an example, I could say that I want nova.api.openstack to have debug level. But I want Nova actually to remain like a critical or something like that. And you can sort of do the same thing with handlers. If you want a log handler which sends a notification to a server to only process errors, then you can do that. You can set the error level, the debug log level to error, and that handler will only handle that error. And it's sort of invisible in the hierarchy, but it's there. It's the root logger. So when you're specifying verbose and debug in your OpenStack configuration files, what it's really doing is it's telling the root logger, I want everything to be logged at this level. And unless a setting is set somewhere further down in the hierarchy for a particular module, that will be the level that everything logs at. So there is some OpenStack specific configuration that occurs. And this is centralized in Oslo log, which is shared among all of the services that I looked at. And because the Python logging module is so flexible, there are certain things the application needs to do to set it up, where it might want to read a configuration file from, stuff like that. So it makes sense, it's centralized. So the basic logging configuration, which is, I imagine, what the majority of people use, you have these two flags, verbose and debug. And one note I noticed when going through the code for this is that if you set verbose to true and debug to true, you'll end up at the info level, not the debug level, because the way that the code is written, it sets the root logger to info, checking the verbose flag after it's actually set the debug one. So watch out for that one. And after it's set that root logger level, it will actually apply all of these things called the default log levels. So this list here is this key value list. What this has in it is logger identifiers in that hierarchy I was talking about, and what level they should be at. So what this means is that if you tweak the debug or the verbose flags, that's not actually going to affect the logging levels of these things that are listed down the bottom here. And one time that this affected me actually is when I was doing some RabbitMQ debugging. I was trying to understand what was going on with Oslo messaging. And if you see on the list there, Oslo messaging is actually set to info. So the verbose and debug flags have no effect. So what you can do is you can set this default log levels setting on in any of the configuration files, and therefore you could set it as blank and you get debug for every single module. That's probably not a good idea, but you can take the default and you can tweak it. Okay. Okay, so one of the other things that you can do is there's this setting called log config append. And if you set this, you set it to a path to a logging INI file. And what this does is that the Oslo config, the verbose, Oslo logging, the debug flag, the verbose flag, they don't take effect. And neither does those default log levels for all those other modules. All of the logging configuration is read out of the configuration file. Now, I've seen in some OpenStack services, they actually have an example of a file which you can use. If not, it's actually just a standard Python logging module configuration file. If you look at the Python documentation, there's a whole tutorial excuse me, on how to use it. And even in your own Python programs, you can use it. It's like a single call. You import logging, you do logging.config.fileconfig, give it the path, and then it'll pull it in. So if you really need to get fine-tuning on your logging, then this is what you can do. And also, this is the mechanism that you could install other logging handlers. So if we talked, like I said earlier, if you wanted to set up like a logging handler that makes an HTTP call or something like that, then this is the most flexible method to configure logging. You can do anything you can do with logging Python logging with this. Okay, so moving on from logging for a bit. So Python uses exceptions for errors. So the way that these work is that somewhere in the code, after many function calls, it detects a problem. Maybe the Python runtime itself detects a problem. It will raise an exception. And that exception will actually filter up through the stack. It's unwound until an except block is found. So I've given quite a kind of a simple contrived example here. So we have a try block. Inside that, I make this function call called show data. Then somewhere down in the depths of show data, it connects to the database, right? But if it has a problem connecting, it will raise an exception. And the except database error there will receive that. And so I'm using the logging library here. It has this .exception method, and that will actually print the trace back to the screen in any method there. That's kind of a basic overview of exceptions. So with that show data here, this will help when we come to talking about stack traces or back traces. They're the same thing. Here's an example of the stack that's occurring with the call to show data. So if you can imagine, you call show data knows that there's a number of fields. So it calls show field for a specific field. Just think we've got a loop going on there and it's calling show field. So it has to get the information for that field, and then it connects to the database. So in the example I gave earlier with the database not being able to connect, what happens is connect to DB raises an exception. The stack unwinds all the way back to where I called show data, and then that ends up getting logged. So a backtrace. Okay, so this is obviously something that's not too easy just to throw on a slide. But what I've actually made this smaller than expected. And I've stripped out a few lines, but to point out some important things on this one here. So as it says at the top, the most recent call is the last call. So if we go right to the bottom there, you can see that where the exception occurred, it was a connection refused. So like, how did we get there? So we go back up to the top. This is the entry point. Now this is a Nova API call. So we went into this. We were handled by a function called double underscore. In Python terminology, that's called dunder. So in this dunder call function, in this init, and then what happened is that if you look down the list here, you can see it went into the security groups module. It then went into the Neutron driver. It went into the Neutron client, so it's about to make a call to Neutron. It went into the Keystone client, which is because the Keystone client actually implements a bunch of base functionality that all the clients have, but it gives you the context. And then finally, it made a call to Neutron, which failed. So what you can deduce really from the traceback here is that the operation that was being performed wanted to get some security group information, or perhaps set a security group. And so it executed and instantiated a Neutron driver and failed. So that's the sort of information that you can get from the traceback. You know, what service it was trying to connect to and why. And the other thing it does, you can see here, is it tells you exactly what Python module was actually making the call, or what line. And then when you look at that line, you'll see where it makes the function call to the next piece of the backtrace. So if you want to add additional logging messages, so this first line at the top here, logger, get logger, so this is the bit where it builds that hierarchy. So dunder name in Python is a special variable, which is the package location in the module. So what that ends up making sure is that, and most OpenStack packages do this, I think all of them actually, is that the logger for a particular module is the same as the package hierarchy, so you know how to set it. So in this example, and this is actually based on the traceback which I had previously. This is where it was generated. The raise line is actually the exception. Is that, and I actually ran into this myself, is that the connection refused message doesn't actually contain any information about what the request library connection error was, because connection refused doesn't actually necessarily mean like a TCP connection refused. It was actually pretty much any kind of connection error got turned into a connection refused. So adding log.error there meant that when I reproduced the issue, that then I got the actual additional information. So that's like a situation in which adding additional logging is useful. And because it's Python, you don't need to recompile it or anything on your test system. You can just edit the file right there in userlib Python 2.7, restart the service, and hopefully you'll get the information that you need. Okay, so execution models. This is a fairly complex topic, but I think it's important when you're reading your log files. So, to kind of give an overview, you typically have these 3 different execution models that apply to any program, any language. You have multi-process, where you do PS on your Linux box, you see multiple processes, or any request can be handled by any of them. Normally when a request comes in, and maybe that calls out to the database, that process will be blocked until the response comes back. But you can do things in parallel, right? Not just concurrently, but they can run simultaneously on multiple CPUs. Now, multi-threaded is similar to multi-process. It's an operating system provided mechanism. They actually, all the threads share memory. They all run inside the same virtual memory space. which has performance benefits when it comes to exchanging information between threads, but it also has the downside that when two threads are working with the same thing, sometimes you have to perform synchronization. Python is not very good at multi-threading due to the design of the interpreter, which is a very long topic, and you can find hundreds of people flaming about it online and trying to figure out what to do about it. But greenlets, they're actually something which you build at the application layer. It's nothing to do with the operating system. And this is a cooperative multitasking. So what happens is you get a coroutine, which is like a special function, which gets called, and then at some point it tries to make it I/O, or it's decided it doesn't need to do anything else, it calls sleep. And that passes control to another function. So this gives you concurrency, because you're doing multiple things at once, but it only uses normally one thread or one process, so they're not actually running in parallel. So why is that important? Okay, so it's about the logging, right? When you look at your logs, you could actually be looking at things that happened at the same time, and it can be difficult to figure out what's going on. Now there are some solutions for some of these, and right now there doesn't seem to be a good solution for the cooperative multitasking, the greenlit mechanism. Now, OpenStack services typically do use that greenlit mechanism. That's like the #1 used mechanism for concurrency. Apart from Keystone recently deprecated that. Now they recommend that you run it under Apache WSGI, which will actually use a multi-process and a multi-threaded model. So when you're looking at the logs, in a multi-process system, like something running like Keystone, you'll actually get the PID, which I put in bold under multi-process there. So that's one way in which you can tell that you're looking at two different requests. So by default, OpenStack doesn't log the thread ID, but again, the Python logger has this concept of a formatter, and that's something you can set with that configuration file that I was talking about earlier. And if you look at the Python documentation, there's one called thread. If you add that to your logging formatter, then you can also get some thread information. And also one thing which Oslo Log has added, so to try and make this problem, to try and solve this problem, make this easier for people, is that if it has any contextual information which is being passed from the logger, like the instance or the project or something like that, that will be added into the log output as well. Okay, so if anyone has any questions, they can go up to the microphone and that's it. All right. Any questions?
Here
yes, they will be. Yeah. Oh, do you have a question?
Just a short one. Can you get me back to slide 15?
Sure. Hopefully.
So here we have the message creation. This underscore operator, is it for localization?
Sorry, we've got what are we talking about here, sorry?
Yeah, where you say message equals unable to establish the connection. So this underscore parentheses stuff.
What, this underscore here?
Yeah, it is for localization.
Yes, that's right. This is actually what's not in bold. The unbolded stuff is what the original code was there. So that's OpenStack localization support. So because I threw this error in like myself, I didn't really worry about localization or anything, so I just put it in there. Okay. All right, thanks very much, everyone.